Welcome to our second module on trigonometry. Today's lesson is about the compound angle formulae. You are familiar with the basic trigonometrical formulae such as sine, cosine, and tangent for a single angle, but those can be extended to compound angles, meaning an addition or sum of two or more angles. So here we have our sine, cosine, and tangent formulae for compound angles. So our sine formula is the sine of A plus or minus B is identical to sine A cosine B plus or minus cosine A sine B. Now, what does this plus or minus sign mean? Well, it means that the plus sign goes with the plus sign and the minus sign goes with the minus sign. So for example, if you have the sine of A plus B, that is equals to sine A cosine B plus cosine A sine B. And similarly, the sine of A minus B is equal to sine A cosine B minus cosine A sine B. So whenever you see this sign in any of these compound angle formulae, just remember to keep what is at top with what is at top and what is at the bottom with what is at the bottom. So for example, cosine of A plus or minus B is identical to cosine A cosine B minus or plus sine A sine B. So that means that the cosine of A plus B is actually equal to cosine A cosine B minus sine A sine B. And vice versa, the cosine of A minus B is equal to cosine A cosine B plus sine A sine B. And finally, the tangent of A plus or minus B is identical to the tangent of A plus or minus the tangent of B all over 1 minus or plus the tangent A tangent B product. So with those said, let's get into an example. Okay, so in this example, we are asked to find the exact value of the cosine of 75 degrees. So we can use our double angle formula for cosine of A plus B is identical to cosine A cosine B minus sine A sine B. I have chosen to use the plus because 75 degrees, I can express that as 45 plus 30. Therefore, I'll have the cosine of 45 times the cosine of 30 minus the sine of 45 times the sine of 30. So 45 plus 30 is 75. That's why I chose 45 and 30. And I chose 45 and 30 because these are our special angles that we should know the exact values of. So the cosine of 45 degrees is root 2 over 2. The cosine of 30 degrees is root 3 over 2. Continuing with the substitutions, the sine of 45 degrees is root 2 over 2 and the sine of 30 degrees is 1/2. Multiplying before we subtract, this will give me the square root of 6 over 4 and this will give me the square root of 2 over 4. The final step would be to simply express these with one common denominator and I'll have the square root of 6 minus the square root of 2. Please do not make the mistake of saying, oh, I can subtract these. No, think of these as unlike terms. This is the square root of 6, that's the square root of 2. Those do not add or subtract. You could multiply them, but that's not what we're doing here. It is simply the square root of 6 minus the square root of 2 all over 4. Let's get into another example. Alright, so in this example, we're to find the exact value of the tangent of 15 degrees. So we'll use our compound angle formula. The tangent of A minus B is identical to tan A minus tan B all over 1 plus tan A tan B. So 15 degrees, we can say that is 45 minus 30 because 45 and 30 are two of our special angles. So I'll have the tangent of 45 minus the tangent of 30 all over 1 plus the tangent of 45 times the tangent of 30. So the tangent of 15 degrees will be 1 minus the square root of 3 over 3 all over 1 plus 1 times the square root of 3 over 3. So simplifying that, I'll have 1 minus root 3 over 3 all divided by 1 plus root 3 over 3, which we can simplify by adding these as one simple fraction, both the numerator and denominator. So this will be 3 over 3. So as one simple fraction, it will be 3 minus root 3 all over 3. And the denominator, 1 can also be expressed as 3 over 3. So that would be 3 plus root 3 all over 3. Here, the denominators of 3 would cancel. So we're left with 3 minus root 3 over 3 plus root 3. So we don't want to have any surds in our denominator. Therefore, we must rationalize the denominator by multiplying by the conjugate of the denominator. So I'll multiply by 3 minus root 3 for both the numerator and denominator. In doing so, I have 3 times 3, which is 9, 3 times negative root 3, and another 3 times negative root 3 will give me a negative 6 root 3, and then a negative root 3 times a negative root 3 gives me a positive 3. For the denominator, 3 times 3 is 9. I'll have 3 times negative root 3 and that 3 times a positive root 3, which will cancel each other out. And then finally, positive root 3 times negative root 3 will give me a negative 3. Simplifying, 9 plus 3 is 12. So in the numerator, I'll have 12 minus 6 root 3. And then in the denominator, 9 take away 3 is 6. So here, when I look at the numerator and the denominator, I notice that both of these terms are divisible by 6. So if I divide both of them by 6, 6 goes into 12 2 times, and the 6's here cancel. So I'm left with 2 minus root 3, and that's the answer. Let's get into another more challenging example. Okay, so with our last example here, we're told that angle A and angle B are both obtuse angles, and the sine of angle A is 5/13 and the cosine of B is negative 3/5. We are to use that information to find the tangent of A minus B. Now here, you might be wondering, why are we told that angle A and B are obtuse angles? How is it that the cosine of B is negative 3/5? Well, keep in mind our 4 quadrants, CAST, right? If they are obtuse angles, that means they are more than 90 but less than 180, hence they are in quadrant 2. Recall that in quadrant 2, sine is positive, but cosine and tangent are not positive, right? They are negative. So that's why this cosine of B is negative 3/5, and that will play a role later on. So if we're to find the tangent of A minus B, remember that our formula is that the tangent of A minus B is identical to tan A minus tan B all over 1 plus tan A tan B. So we'll need the tangent of A and the tangent of B to substitute into our formula. But currently we have the sine of A and the cosine of B. So how can we find the tangent of A and the tangent of B? Well, let's proceed to draw a little diagram. If this is our angle A, right? Let's say this is a right angle triangle. Never mind that it is actually an acute, right? That's not important here. What is important is we can visualize that if the sine of A is 5/13, that means that the opposite side is 5 and the hypotenuse is 13. So if we look at this, we have a right angle triangle with 2 sides that we know, 5 and 13. Those are 2 parts of a Pythagorean triple. 5 blank 13. What's the missing side? It is 12. Now, since angle A and angle B are both obtuse angles, then that means that the tangent of angle A will be negative 5/12 because in quadrant 2, tangent is negative. When it comes to angle B, our little diagram here, we can use that the adjacent side is 3 and the hypotenuse is 5. So if we have 3 and 5, what's our missing term from that Pythagorean triple? Well, it's 3, 4, 5, right? So this side here has to be 4. So the tangent would be a negative 4 over 3. Again, why negative? Because if it's an obtuse angle in quadrant 2, then tangent is negative. So now we have our value for tangent A and tangent B, we can substitute into our formula. So the tangent of A is negative 5/12. From that, right, we're going to subtract negative 4/3. And then in the denominator, it's negative 5/12 times negative 4/3. So negative 5/12 take away negative 4/3 will give you 11/12. And then negative 5/12 times negative 4/3 will give you a positive 5/9. So it's 11/12 divided by 1 and 5/9. Simplifying that, you'll get 33 over 56. And that's our value of the tangent of A minus B. So that's the end of this lesson. See you in class.